Okay, let's unpack this. There's a real buzz, isn't there, around AI right now, and it feels, different from tech cycles I've seen before. And I've been lucky. I've seen a few over, 4 decades now. The PC back in the 80s, putting computers on desks, then the web hit in the 90s, connecting everyone, crazy times. Then mobile, the 2000s, suddenly supercomputers in our pockets, and then cloud, making it all accessible. Each one felt huge, transformative, right? Reshaping everything. But this AI moment, it just feels, more foundational somehow. Like the bedrock is shifting, how we get things done, how we interact with info. It's not just another upgrade, is it?
You're absolutely right. That's a really crucial distinction to make. For so long, AI had this sort of rhythm, didn't it? These big hype cycles, the AI summers, full of promises. And then, often, the cold winters, where things didn't quite live up to the hype, disillusionment set in. But this time, it feels profoundly different. The whole conversation is shifted. It's palpable. It's moved beyond just speculation to real, tangible impact. You could say if the last, 18 months were all about the engine itself, the incredible, almost vertical rise of LLMs, large language models showing what they could do with language, then this next era, the one we're stepping into right now, is definitely going to be about the car we build around that engine. It's about creating those sophisticated systems, those frameworks that harness that raw power, turning it from just, generating plausible text into something that takes purposeful action, something that can actually navigate complex tasks.
And that, dear listener, is exactly what we're here to do today. That's our mission. We're diving deep into this book, Agentic Design Patterns, a hands-on guide to building intelligent systems. We want to understand, in really practical terms, how you can build that car around this incredibly powerful LLM engine. Now, for you, I know you've already got some solid experience. You've built things like customer support chatbots. You're proficient with prompt engineering. That's fantastic. So this deep dive, it's really your next logical step. Think of it as a way to accelerate your journey in AI development. We're aiming to give you a shortcut, really, to being super well informed on taking your skills up a level, especially with your amazing goal using AI creatively, efficiently to support domestic violence crisis response organizations. That's incredibly impactful. So this isn't just about building any AI, is it? It's about building AI that really matters, building meaningful AI.
Indeed. And that's exactly the aim. We want to give you a kind of structured mental roadmap through the core ideas in this really groundbreaking book. We'll demystify what these agentic systems actually are. We'll dig into why they're such a big leap forward. And crucially, we'll equip you with a solid foundational understanding of how you can actually start building them. So throughout our chat, we'll break down the key concepts, the technical terms, those architectural shifts that really define this new frontier. And we'll do it in a way that's not just clear, but hopefully immediately actionable for your own projects.
Right. And we promise, no fluff here, no jargon, just for the sake of it. Just, thoughtful questions from my end, trying to get clarity, and structured explanations from our expert here, making it all smooth and intuitive. Together, we'll look at how AI evolved from simple models to these autonomous systems. We'll unpack what really makes an agent an agent. We'll climb those different levels of agent complexity. That pyramid idea is great. And then finally, we'll look at those really crucial design patterns, your blueprints, basically, for building solid, effective AI solutions.
Absolutely. And as we navigate all this exciting stuff, we'll keep coming back to the huge importance of applying these patterns responsibly, ethically, especially given your goal with domestic violence crisis response. The stakes there are incredibly high. The systems you build have to reflect that gravity. So yeah, we'll explore the what and the why for sure, but we'll really focus on the how, giving you that deep understanding you need to develop truly advanced, impactful, and importantly, trustworthy AI solutions that can make a real difference.
So when we talk about this new era of AI, it really is fundamentally different, isn't it? It's not just models churning out text that sounds good anymore. You mentioned Marco Argenti, the CIO at Goldman Sachs. You'd think someone like that would be pretty analytical, maybe a bit skeptical about new tech buzz. And he actually admitted, he started out as a profound skeptic. He said his initial feeling was that early LLMs often seemed optimized for credibility over correctness. Which is a great phrase. Think about that. They could generate text that sounded super authoritative, really fluent, but then you dig in and maybe the facts were shaky or the advice was just plain wrong. For someone in finance, where accuracy is everything, while an LLM confidently making up plausible but wrong financial advice, that's a huge red flag, right?
Yeah.
So he was understandably skeptical about how useful they really were beyond just novelty.
Oh, absolutely. That skepticism was really common, and honestly for good reason. For a long time, LLMs were essentially these, sophisticated statistical machines, brilliant at predicting the next likely word based on tons of data. They got really good at mimicking human language, but the understanding, quote unquote, was pretty shallow. But then something shifted, a big shift, what Agentic calls the inflection point. This happened with a new class of models, these reasoning models. And that was the moment, he says, when we started getting a peek into a nascent form of cognition, moving beyond just plausible text to something deeper, something that hinted at an actual thought process underneath. It felt like the AI wasn't just saying things, it was maybe thinking about them.
Right. And he described this spark of magic moment he had. He gave one of these new agentic coding tools a personal task he'd been putting off. It was migrating a charity website from a simple builder to a proper CI/CD environment. For those maybe less familiar, CI/CD basically automates the whole software delivery pipeline, coding, testing, deploying, makes it smoother. Anyway, he just watched this agent, this digital assistant, work for like 20 minutes, and it wasn't just quietly running code, it was asking clarifying questions. It asked for credentials it needed. It gave status updates, just like a junior developer might. And then at the end, boom, a fully deployable package with great documentation, unit tests too. He said he was, and I quote, absolutely floored. It felt less like using a tool and more like, I don't know, collaborating with a junior team member, a real one.
It's a fantastic story, really brings it to life. But, and this is important, it also highlights a really crucial caveat. Argenti is quick to point out, it wasn't perfect. It made mistakes. It got stuck. And that experience really hammered home the need for human supervision, human judgment. You need to monitor the agent, understand why it's doing what it's doing, and nudge it back on track if it goes off the rails. His big takeaway, learned over years in complex systems, was you cannot afford to trust blindly. You just can't. But even with the flaws, the process itself was fascinating. He could look into its chain of thought, the steps it was taking, the tools it tried, how it corrected itself. And it was like watching a mind at work, he said, messy, nonlinear, full of starts, stops, and self-corrections. Very much like how we humans solve problems, right?
Yeah.
Not always a straight line. Sometimes it's kind of a random walk to the solution. And that's key. It wasn't just following a script. It was trying to reason, trying to adapt.
That is a crucial distinction. So the fundamental shift there, it's not just better output, is it? It's something deeper.
Exactly. The core insight from that experience, and really from this whole rise of agentic AI, is this. The agent didn't just generate content. It generated a plan. That's not just an upgrade. It's a whole paradigm shift. The key thing here is moving from fixed logic to adaptive iteration. These agents aren't just following code line by line. They're constantly refining their strategy, their execution in real time based on what actually happens. It mimics a really fundamental part of how humans learn. So it's this ability to generate a plan, execute it, and this critical, adapt that plan on the fly. That's the defining promise of these agentic frameworks.
That makes perfect sense. The analogy you used, it's like the difference between a static subway map, one fixed route, and a dynamic GPS. The GPS reroutes you if there's traffic or a closed road or you suddenly decide to go somewhere else. A classic rules-based system, it just follows its path, hits an unexpected problem, it breaks or gets stuck. But an AI agent, powered by one of these reasoning models, it has the potential to observe, adapt, and find another way. It can replan. This idea of digital common sense lets it handle those countless edge cases of reality that you just can't program for in advance.
Precisely. And it really represents this fundamental shift. We're moving from simply telling a computer what to do to explaining why we need something done and trusting it to figure out the how.
Yeah.
It's a totally different way of interacting, much closer to genuine collaboration with AI.
Okay, the GPS analogy is great for adaptability, but I'm thinking building that digital common sense for complex human situations must be way harder than just routing around traffic jams. What are the specific hurdles in teaching an AI agent to really grasp the why in something as nuanced as a crisis situation, not just spot keywords?
That's a really insightful question, and it gets right to the heart of the challenge. And frankly, the responsibility here, especially for your goals. Teaching an AI the why in a crisis like domestic violence. Yeah, that's leagues beyond keyword spotting. You're talking about inferring emotional states, understanding unspoken context, recognizing hidden dangers, dealing with cultural sensitivities. It's incredibly complex. Some big hurdles are, 1, lack of embodied experience. Agents don't feel empathy, fear, or understand power dynamics like humans do. Their understanding is based on language patterns, not lived experience. 2, data scarcity for nuance. Training data, even massive amounts, struggles to capture the full spectrum of human distress, especially subtle cues or trauma narratives. And creating synthetic data for this, ethically tricky and hard to get right. 3,
Generalization versus specificity. A model trained on the whole internet might not apply its common sense correctly to the very specific, sometimes counterintuitive dynamics of abuse. A victim might not say abuse, right? They might talk about fear, control, isolation. The agent needs to connect those dots.
4. Avoiding harmful simplifications. Trying to boil down a complex human crisis into a neat AI problem can lead to really dangerous or unhelpful responses. The why is deeply human. And 5. Maintaining trust and empathy. Humans build trust through shared understanding. AI empathy is simulated. So building trust needs transparency, reliability, and acknowledging its limits. Which brings us back to responsibility. But, despite these huge challenges, think about the potential leap for you coming from chatbots. Instead of a bot following a fixed script, imagine an agent that uses its reasoning to truly understand the why behind a crisis call. It could dynamically change its response. Maybe find immediate local help, offer specific support based on inferred needs, or maybe seamlessly hand off to a human, but give them a concise summary first. This ability to get the context, adapt, execute multi-step plans, that's the new frontier for building really impactful AI for crisis response.
Okay, so given this huge leap, what does it all mean for you, the builder? We've talked about the shift, but let's get down to basics. What actually is an AI agent? The core definition seems to be a system designed to perceive its environment and take actions to achieve a specific goal. So it's much more than just smart output. It's about smart action, right?
Exactly. To build on that, you can think of an AI agent as an evolution from your standard LLM. It's enhanced with these crucial abilities to plan, to use tools, and importantly, to interact purposefully with its surroundings. Don't think of it like a calculator or a word processor. It's more like a smart assistant that actually learns as it goes. It's constantly observing, refining its approach. It operates through this kind of iterative 5-step loop to get things done. You can picture it as the agentic AI problem-solving process. It's not strictly linear, it's a cycle.
Right. Let's walk through that cycle step by step. I think that really helps clarify how these things work dynamically. So first, step 1 is get the mission. This is where you give it the goal, right? Like, organize my schedule for next week, make sure client meetings are prioritized. That's the starting point, the directive.
Precisely. Then comes step 2, scan the scene. Here, the agent actively pulls in information from its environment. It needs context to figure out how to achieve the mission. For that scheduling task, it might need to read your emails, check your different calendars, maybe look up client details in your contacts. It might even check traffic or time zones if meetings are involved. It's basically assessing the situation, perceiving its environment, just like a person would.
Okay, got the info. Then step 3, think it through. This is the planning part.
That's right. This is where the core reasoning kicks in. The agent processes all that info it gathered, uses its internal knowledge, and comes up with a plan. It breaks the main mission down into smaller steps. For scheduling, it might think, okay, first, find all client meeting requests. Second, identify free slots. Third, check for clashes. Fourth, draft and send invites. It's strategizing, trying to find the best way to hit the goal you set, maybe even thinking about potential problems.
Makes sense. Then step 4 is take action. Time to execute the plan.
Exactly. It actually does the things it planned. Sends those invites, puts events on the calendar, sends reminders, maybe tells other people involved. These are concrete actions, things that change its environment and move it closer to completing the mission.
And then the crucial 5th step, learn and get better. This makes it iterative, right?
Absolutely. This is where the real learning happens.
Yeah.
The agent looks at the results of its actions. Maybe a meeting it's scheduled gets canceled by someone else, or a client replies saying they prefer mornings. The system takes that feedback in, it learns from it, adapts its internal models, refines how it plans next time, improves over time. It's this constant loop, observe, act, learn, correct, just like how we learn from experience. And again, that key insight. It's moving from fixed logic to adaptive iteration. It's not just running a program, it's learning and adjusting based on real results.
Wow. Okay, applying that loop to your work, to crisis response, you can really see the power.
Oh, definitely. Imagine an agent whose mission is to provide immediate, full, empathetic support. It scans the scene by analyzing what the user types or says, not just words, but maybe urgency, tone, implied needs. Then it thinks it through, assesses danger, figures out protocols, plans the best actions, maybe including handing off to a human, then takes action, provides specific local resources, contacts a human responder, guides the user through safety steps like how to report something, and crucially, it learns and gets better every time. If a resource didn't help or one way of talking worked better, it refined its approach. It gets better at providing empathetic, practical help, adapting to the really sensitive, changing needs of survivors.
That's a world away from just a static FAQ page. It's dynamic support.
So beyond that five-step loop, what are the defining characteristics? What makes something truly agentic and what makes it complex to build?
Yeah, the book lays out several key features in the intro, and each one brings its own design headaches, basically.
Hmm.
First, autonomy. Agents can act, make decisions, without someone constantly watching over them, which is tricky, right? They need to handle unexpected stuff gracefully. Then, proactiveness. They don't just wait for orders. They initiate actions towards their goals. That means understanding intent, anticipating needs. They also need reactiveness, responding effectively quickly to changes around them. So they need to monitor things, filter out noise. Fundamentally, they're goal-oriented, always working towards objectives and able to rethink their path if needed. A big one we mentioned, tool use. Connecting to external APIs, databases, services. That means smooth integration with different systems. They need memory, remembering info, context, cross-interactions, sometimes over long periods, which is tough for LLMs with their context limits. You need clever ways to recall the right info. And finally, communication. Talking to users, other systems, maybe even other agents. Needs clear protocols, good messaging.
Okay, so contrasting that, a traditional customer support system might just follow a rigid script for a simple question. But an agentic system, it'd be way more dynamic. It might perceive the nuances, maybe pick up on frustration or a deeper issue. Then it could access knowledge bases, interact with other internal systems, orders, customer records, whatever. It might even ask clarifying questions to really pin down the problem and then proactively resolve the issue, maybe even suggest other helpful things. It sounds much more like a helpful human interaction.
Exactly. But, and this is the builder's challenge, making those characteristics real. It's not trivial. It adds a ton of complexity. You immediately hit tough questions, like how does the agent keep track of the conversation state across multiple turns? That's state management. Or how does it figure out when to use a tool and which tool is the right one? That's tool selection and routing. How do you manage communication if you have multiple agents working together? That's coordination. And maybe most importantly, how do you build in resilience? Make sure it handles errors gracefully, especially if it's acting autonomously. These are exactly the kinds of tough problems that these agentic design patterns are designed to help you solve. They give you tested blueprints for these common, complex issues.
And speaking of complexity, the speed of change here is just mind-blowing, isn't it? This isn't some niche lab tech anymore. I saw stats saying most big IT companies are already using agents, and like a fifth of them only started in the last year. It's not just talk. Businesses are actually changing how they work. And the money folks are definitely noticing, what was it? Over $2 billion raised by AI agent startups by end of 2024, market valued at $5.2 billion then, predicted to hit nearly $200 billion by 2034. That's like a 40x jump in a decade. That's serious growth, like early internet or mobile kind of growth. It feels like agents are going to be massive. Which leads us to this idea of a paradigm shift.
Yeah, it really underscores this rapid AI paradigm shift we've witnessed really just in the last couple of years. We've gone from simple LLM wrappers to potentially truly intelligent systems. You can kind of picture the progression. Started with basic LLM workflows, simple prompts, triggers, getting models to process text, foundational stuff. Then came our retrieval augmented generation. You'll know this well from prompt engineering. Grounding models in real data, making them more reliable, less likely to just make stuff up. Huge step. From there, we got individual AI agents. These could do more than RAG. They could use tools, remember things, plan steps to reach a goal. But where we're really heading now, the focus of this book is agentic AI. This is the top tier, where you have a team of specialized agents working together, collaborating to tackle really complex goals. That's a massive leap. It's about collective intelligence, not just one smart model. The idea is the future isn't one giant superbrain AI. It's more like a symphony, right? Specialized intelligences playing together. This whole journey, from single prompts to collaborating teams, that's what we're digging into.
And that's precisely the book's focus, right? Discussing the design patterns for how these specialized agents can work in concert and collaborate, looking at the different ways they can interact and work together. It's about building the whole symphony, not just tuning one violin, orchestrating intelligence. That's a great way to put it.
Right. And to really get a handle on the power here, especially thinking about your sensitive applications, it helps to see agentic systems on a kind of spectrum, a spectrum of complexity. The book uses this great visual, an agent complexity pyramid. It shows the range, right?
Yeah.
From basic LLMs at the bottom, all the way up to those complex collaborating multi-agent teams at the top. You can think of it as your mental roadmap as you build these things, guiding you from the simpler ideas up to the more advanced stuff.
That sounds really helpful. A roadmap. Okay, so what does this mean for you, the builder? Let's break down those levels, starting at the bottom of the pyramid.
Okay, so at level 0, we have the core reasoning engine. This is the absolute foundation. It's the large language model itself. Now, an LLM at this level, It isn't really an agent yet, not in the full sense, but it's the reasoning core, the brain, if you like. At level 0, the LLM operates totally solo. No external tools, no long-term memory beyond its context window, no direct interaction with the outside world, other than getting a prompt and giving a response. It just uses its pre-trained knowledge. Everything it knows is baked in from its training base.
So its strength is really using that massive training data, right? Explaining concepts it was trained on, generating creative text within those limits. But the big limitation, as you said, is it's cut off from the present. No awareness of current events, no access to real-time info. So yeah, ask it who won the big game last night.
Yeah.
Or about a new scientific discovery. If it happened after its training cutoff, it has no clue. It's the raw engine. Powerful with language, but isolated from the now. Can't learn anything new after training.
Exactly. Now, move up to level 1, the connected problem solver. This is where the LLM starts to become a proper functional agent. How? By connecting to and utilizing external tools. Suddenly, its problem-solving isn't stuck with just its pre-trained knowledge. It can now execute a sequence of actions, maybe multiple steps, to go out and get information from external sources. That could be searching the web using a search tool for today's news, or querying a specific company database, or using retrieval augmented generation, RAG, to pull in relevant documents. And Chapter 14 in the book really digs into RAG, which I know is relevant to your background.
Right, you can see it where, like, if it needs to recommend new TV shows, it knows its internal info is old. So it uses a search tool, finds recent releases, reads reviews, then puts it together for you. Or maybe more technically, it could call a finance API to get Apple's livestock price. Then maybe use another tool for historical data. Then give you a summary. It's this ability to reach out, use specialized tools, maybe over several steps, to get a job done that's the core of a level 1 agent. It's not just talking, it's acting on the world, pulling in live data.
And think about the impact for your work in domestic violence crisis response. Immediate, potentially life-saving. A level 1 agent gets a plea for help. It doesn't just understand the words and give generic advice. It knows it needs local, current info. No. So it uses a tool, maybe connects to a secure API for a vetted list of local services or a specific shelter directory, and instantly finds available emergency shelters, legal aid numbers, counseling services right there near the user. That's moving beyond just understanding to acting with real-world resources, providing immediate, actionable help. That cuts response time when minutes matter.
Okay, that's huge. Now, level 2. The strategic problem solver. This sounds like a bigger jump. Strategic planning, proactive help, self-improvement. And you said this is where prompt engineering skills really shine, alongside something new, context engineering. So it's not just using tools, but using them smartly.
That's exactly it. Level 2 is a significant step up. The agent goes beyond just simple tool use or basic sequences. It tackles complex, multi-part problems using real strategic thinking. And as it works through a plan, it actively performs context engineering. This is a really strategic process. It intelligently selects packages and manages only the most relevant information for each specific step it takes. It's about managing the model's focus, its limited attention.
Okay, give me an example. How does that work?
Right, say you want to find a well-rated coffee shop exactly halfway between two places, and you need to know if it has outdoor seating. A level 2 agent would first use a mapping tool to find that midpoint. But then it wouldn't just dump all the raw map data, every street name, coordinate random detail into the next step. That's too much noise. Instead, it engineers that output. It curates a short, focused context, maybe just the midpoint coordinates and a search radius, or a few key street names. It feeds that curated context into, say, a local business search tool. This stops the language model getting overwhelmed. They have limited context windows, remember. It makes the second step efficient, accurate, and probably cheaper to run. The book calls context engineering the skill that effectively curates the model's limited attention to prevent overload and ensure high-quality, efficient performance. Appendix A goes deep on this. It's critical.
Okay, I see. Filtering the noise, focusing the signal for the next step.
And given your skill in prompt engineering, this is such a natural progression for you.
Yeah.
But it's powerful. Imagine you're a crisis response agent at level 2. It gets a long, maybe rambling, emotional message from a survivor, lots of detail, maybe confusing. It doesn't just try to process everything at once. It strategically engineers the context. It pulls out the absolute key, actionable details, most recent location mentioned, the immediate danger level, any specific needs like kids or pets. It creates a short, focused, powerful context from that noise. Then it uses that focused context for the next tool calls. Maybe filtering a huge resource database for only shelters available right now, or crafting a super precise query for an emergency API. This ensures help is fast and accurate when seconds count, without confusing the system or a human responder with a relevant history.
And you mentioned proactive operation, too.
Yeah. At level 2, agents can start acting without being explicitly asked for every single thing. Like a travel assistant linked to your email and sees a flight confirmation email land. It doesn't wait for you. It autonomously engineers the context, pulls out flight numbers, times, dates, places from that long email. Then it proactively uses tools, calls your calendar API to add the flight, calls a weather API to check the forecast for your destination, all on its own initiative. Or in software development, a level 2 agent gets assigned a bug report, it reads it, accesses the code, then engineers those big sources into a focused context to write the fix, test it, submit it, maybe even update the bug tracker. It's managing a whole workflow.
Wow, that's a real step towards automation and
Yeah.
self-improvement. How does that work?
This is really exciting. Level 2 agents can start self-improvement, refining their own processes. How? Well, maybe after finishing a task, the agent asks for feedback. Could that prompt have been better? Was the plan efficient? It's not just being polite. It's actively learning how to better curate its inputs, how to plan more effectively next time. It can automatically improve how it packages info, chooses tools, sequences steps. It creates this automated feedback loop so it gets more accurate, more efficient over time, all by itself. Chapter 17 looks at the reasoning techniques behind this kind of self-refinement.
Okay, for crisis response. That means an agent that learns from every interaction. Maybe it learns that certain subtle phrases signal higher danger, or that a particular sequence of resources works best for specific situations. So it continuously refines how it interprets distress signals, how it responds. It becomes more effective, more empathetic over time, more insightful, more adaptable. That could lead to much better outcomes.
Exactly. Which brings us all the way up to level 3, the rise of collaborative multi-agent systems. Now, this is truly a major paradigm shift. We're moving away from the idea of creating one single, all-knowing super agent. Instead, the focus shifts to building sophisticated teams, collaborative multi-agent systems. The core idea is that complex problems are often best solved, not by one generalist, but by a team of specialists working together, each with a specific role, specific expertise. It really mirrors how human organizations work, doesn't it? Different departments, different teams, all collaborating on big goals. The power comes from dividing the labor and the synergy you get when they work together effectively. This allows for automating incredibly complex workflows. Chapter 7 dives right into this.
Okay, paint a picture. How does that work in practice?
Sure. Think about something complex like launching a new product. Instead of one agent trying to juggle everything, you might have a project manager agent acting as the coordinator. But the PM agent doesn't do all the work. It orchestrates. It delegates tasks to other, more specialized agents. Maybe a market research agent digs into consumer data and trends. A product design agent works on concepts and prototypes. A marketing agent creates the campaign materials and runs them. The absolute key is seamless communication between them. Sharing information, coordinating efforts, making sure everyone's pulling in the same direction towards the main goal. The project manager agent oversees it all, maybe resolves conflicts if agents disagree.
Right, a team of AI agents. And for crisis response, that sounds incredibly powerful.
It really is. Imagine a crisis coordinator agent gets the first report from a survivor. It could then intelligently delegate tasks, maybe to a specialized triage agent, to quickly assess the danger and emotional state. Then a resource finder agent gets tasked with locating local help shelters, legal aid, counseling, and maybe a follow-up scheduler agent makes sure there are check-ins, ongoing support arranged. This kind of multifaceted collaborative approach allows for a really comprehensive, nuanced response. It covers all the angles in complex, sensitive situations and makes sure critical aspects aren't missed. It's a much more robust, adaptable support system than one agent could ever be.
Okay, that vision of autonomous AI teams. It sounds amazing, but also really complex. If they're so powerful, why aren't level 3 systems everywhere already? What are the big roadblocks right now?
That's a very fair question. It highlights where the cutting edge is and what challenges we're still working through. It's not quite plug and play yet. There are definitely hurdles. 1, reasoning limitations. Even the best LLMs can still hallucinate or make logical errors, especially in long, complex chains of thought. In a multi-agent team, one agent making a mistake can throw the whole team off course. Reliable coordination is hard when the individual agents aren't perfectly reliable. 2, coordination overhead. Just like human teams, these agent teams need really good communication, clear task delegation, ways to resolve conflicts. Designing those protocols to be efficient, clear, and scalable. That's a big technical challenge. Getting agents to genuinely learn from each other, share context well, and update their collective plans smoothly. We're still in the early days of figuring that out. 3, state management. keeping track of the whole team's status, who's doing what, the shared understanding of the situation, especially over a long task. That's computationally hard and tricky to manage reliably. And 4, debugging. When something goes wrong in a complex team of agents, figuring out what went wrong, which agent messed up, and fixing the intricate interactions, that can be a nightmare. It slows down development. So overcoming these bottlenecks is the big focus now, especially improving the core reasoning of the LLMs and building better ways for agents to talk and learn together. But when we crack those nuts, that's when we'll unlock the profound promise of this level, the ability to automate entire workflows, start to finish, with incredible intelligence and adaptability. The potential is staggering, but yeah, we're still paving that road.
Okay, so we've gone through these levels, from the basic engine up to these complex collaborating teams. It's clear that building these systems is, well, it's a serious undertaking, way more than just coding. The book uses this great metaphor, right? Building these systems is like creating art or engineering something complex on a canvas.
Yeah, and that canvas isn't a blank visual space. It's more like the whole environment. The underlying infrastructure, the frameworks, they give your agents a place to live and work. Think of it as the workshop where your intelligent app comes together. It's the foundation. It's responsible for handling all the essential plumbing, managing state memory, handling communication between agents or with users, controlling access to tools, managing the flow of logic, the steps. It's everything that lets your agents operate reliably and consistently. It gives them ground to stand on, air to breathe, tools to use.
So what does that mean practically for someone like you, ready to build? It means you can't just, I don't know, toss components onto the canvas and hope it works, right? Or keep solving the same basic problems over and over. Building well requires understanding these proven techniques, these patterns. You need a strategy.
Precisely. Agentic design patterns are essentially battle-tested templates or blueprints. They offer proven ways to tackle the standard challenges you hit when designing and building agents. They aren't super rigid rules you have to follow exactly. Think of them more as flexible, reusable solutions that we know work well in different situations. It's just like how design patterns transformed traditional software engineering years ago. They gave us a common language, standard solutions for object-oriented problems. These agentic patterns, they're becoming just as foundational for building robust, scalable, reliable, intelligent systems now. They're about smart, repeatable problem solving.
And the benefits seem really clear, especially for creating impactful AI. These patterns enhance structure, right? Make agents more organized, easier to debug, easier for others to understand. They improve maintainability. So updating things, fixing bugs later on isn't such a nightmare. They boost reliability, help you build tougher systems that can handle errors, unexpected inputs crucial if they're acting autonomously. And ultimately, they increase efficiency. They streamline development, help you build faster, better.
They absolutely do on all those points. Using established patterns means you avoid reinventing fundamental solutions every single time. Things like managing a complex back-and-forth conversation, integrating different external tools smoothly, or coordinating a whole team of agents. Patterns give you a common language, a shared structure. It makes the agent's logic clearer to everyone, including your future self trying to maintain it. By using patterns specifically designed for, say, error handling, or managing conversation history, or ensuring data flows correctly, you directly build more robust, reliable systems. And leveraging these known solutions, it speeds things up massively. You can focus your brain power on the unique, critical parts of your application, the stuff that really matters for your users, instead of wrestling with the basic mechanics of how agents should behave. It's about building smarter.
And again, for your goal-building AI, for domestic violence crisis response, reliability and maintainability. They're not optional. They are absolutely critical. Using these patterns helps ensure the systems you build are solid enough, robust enough for those incredibly sensitive interactions. It lets you focus your energy on the really hard parts, the human challenges of crisis support, the empathetic communication, linking with local human services. You can do that knowing the underlying AI mechanics, the planning, the tool use, the memory are built on sound, well-understood principles, less likely to fail unexpectedly. You're not constantly fighting architectural fires.
Right. And to give you a taste of this toolkit, the book pulls out 21 key design patterns. These are like the fundamental building blocks, the core techniques for building sophisticated agents. They cover the whole range. From foundational stuff like structuring sequential operations, that's prompt chaining, linking prompts together, and handling external interactions with tool use, all the way to more advanced topics like getting agents to work together with multi-agent collaboration, or making them improve themselves with self-correction. We're talking about patterns like reflection, where an agent critiques its own work to improve it, Or tool routing, where it intelligently picks the best tool for the job at hand. These aren't just abstract ideas, they're practical answers to real problems you'll face building agents.
And what I love is how practical the book seems. Each chapter is like a mini guide for one pattern. You get a detailed pattern overview, then practical applications and use cases showing where you'd use it. Then, the really valuable part, a hands-on code example using actual agent frameworks, plus key takeaways and references. So you're not just getting theory, you're getting code you can run and mess with. That's gold for a hands-on developer.
Yeah, and people also ask, AI is changing so fast, won't a book be outdated instantly?
Yeah.
But actually, the motivation was kind of the opposite. It's because things are moving so quickly, with new models and tools popping up all the time, that we need to step back. We need to identify the underlying principles, the abstractions that are actually becoming stable. Patterns like RA, reflection, rooting, memory, these core ideas in the book, they're becoming the fundamental building blocks, the grammar of agentic systems, you could say. So the book is really an invitation to think about these core ideas that give you that essential foundation you need to build reliably, scalably, even when the landscape keeps shifting. Without patterns, every project is just chaos.
And to make those code examples concrete, to provide that canvas, the book mainly uses 3 big agent development frameworks, right? Showing how patterns look in real tools.
That's right. It uses LangChain and its cousin LangGraph. These are really flexible, powerful for chaining models and components together, great for building complex sequences, graphs of operations, gives you fine-grained control over multi-step agent behavior. Then there's Crew AI. This one's more structured, specifically designed for orchestrating multiple agents, assigning roles, managing tasks, ideal for those collaborative level 3 type systems. And also the Google Agent Developer Kit, Google ADK. This offers a pretty comprehensive suite of tools for building, testing, deploying agents, often tied into Google's AI ecosystem. Another solid environment.
So seeing examples across these different tools gives you a broader perspective, right? You see how the pattern works regardless of the specific technical environment you choose. The focus stays on the pattern's logic, how it solves the problem, not just the syntax of one particular tool. That makes the knowledge much more transferable.
So as we get into these really capable agentic systems, it's absolutely vital we circle back to that sense of responsibility Marco Argenti talked about. He makes this stark contrast that really hits home. An agent that makes a mistake while creating a recipe for a chicken salmon fusion pie, it's a fun anecdote. Okay, weird recipe, but low stakes. An agent that makes a mistake while executing a trade, managing risk, or handling client data is a real problem. The stakes just skyrocket when these systems move from trivial stuff to the real world, impacting money, safety, health. A tiny error in a trading agent could mean huge losses. A flaw in a medical agent could lead to misdiagnosis. The consequences scale dramatically with how critical the agent's job is.
Absolutely. And that cautionary tale he shared, it sticks with you, doesn't it? The web automation agent that, after failing a login, decided to email a member of parliament to complain about login walls. It's funny, kind of dark humor, yeah. But it's such a sharp reminder that we're dealing with a technology we don't fully understand. An agent, acting on its own, can do completely unexpected things based on how it interprets its goal. And the results can range from just embarrassing to, well, in some situations, truly catastrophic. It really underlines why careful design and oversight are non-negotiable.
Exactly. And this is where he says craft, culture, and a relentless focus on our principles become our essential guide. It's not just about code. It's about how we approach building. He shared Goldman Sachs' engineering tenets, not as strict rules, but as a compass for navigating this new territory. First, build with purpose, ensuring that every agent we design starts from a clear understanding of the client problem we are solving. Okay. So don't just build tech for tech's sake. Don't build an agent that might actually make a problem worse, even with good intentions. Like, a generic legal advice agent in a crisis could be harmful if it doesn't know local laws. Purpose first. Second, look around corners, anticipating failure modes and designing systems that are resilient by design. This means really thinking hard about what could go wrong, threat modeling, not just how it should work, but how it could fail. What if a tool it relies on goes down? What if the user input is ambiguous or deliberately misleading? What if the agent hallucinates a critical fact? For an agent handling sensitive data, maybe that means encrypting everything or having circuit breakers if external systems seem unreliable. And maybe most importantly, inspire trust by being transparent about our methods and accountable for our outcomes. This means building agents where you can understand why they made a decision, interpretability, being honest about their limits, having clear ways for humans to step in, validate, or override. It's about ensuring that when an agent acts, we know why, and we take responsibility for the impact.
Wow, those tenets feel incredibly relevant for your mission.
Absolutely critical, I'd say, for building AI for domestic violence crisis response. Build with purpose means deeply, empathetically understanding the human reality of domestic violence, making sure every single design choice prioritizes the survivor's safety and well-being, never accidentally increasing risk. Look around corners means rigorously thinking through every possible failure, misinterpreting a cry for help, giving the wrong resource, failing to protect privacy. The cost of failure is immense, potentially life-threatening. You have to anticipate and safeguard against harm. And inspire trust means total transparency. How does the AI work? What can it do? What can it do? Taking full accountability for its actions, both to the users and to the human support teams involved. Like Agentic said, messy systems plus agents are a recipe for disaster. And that's doubly true here. It just highlights why you need that solid foundation. Clean data, consistent metadata, well-defined APIs. Building that reliable interstate system for agents is crucial to avoid digital chaos causing real-world harm.
That really brings home the ethical side, doesn't it? Not as an add-on, but baked into the design from the start. But ultimately, this whole journey, it's not about replacing human ingenuity, but about augmenting it.
Right.
Empowering people, helping human responders focus on the most human parts of their work, the empathy, the complex judgment.
Exactly. And it means we, the builders, need a new set of skills. Our role changes. We need the ability to explain a task with clarity, not just coding it, but really articulating complex goals for an AI. We need the wisdom to delegate, knowing what tasks an agent is genuinely good at and where humans must remain in control. And crucially, the diligence to verify the quality of the output, never assuming the agent is perfect, always checking. It also demands humility, acknowledging what we don't know and committing to continuous learning in this incredibly fast-moving field.
Which is why that hope expressed in the book is so powerful, that you will use them not just to build what is possible, but to build what is right, what is robust, and what is responsible. It's about ethical craftsmanship, isn't it? Applied to potentially the most powerful tools we've ever had.
Well said. And looking ahead, it's just fascinating to think about where this is all heading. Agent development is racing forward. What we have now is impressive, but it's really just the start, the next wave, probably focused on making agents more reliable, collaborative, and deeply integrated into our lives. The book outlines 5 leading hypotheses for what's next, a glimpse into a future that could really reshape how we live and work.
Okay, let's quickly touch on those 5, maybe linking them back to your goal where possible. What's the future look like? Hypothesis 1, the emergence of the generalist agent. This idea is agents moving beyond narrow tasks to become true generalists, handling complex, ambiguous, long-term goals reliably. For crisis response, imagine an agent managing a long-term support plan for a survivor. Safety planning, legal resources, mental health connections, all over weeks or months, adapting as things change, like a human caseworker might, dynamically adjusting its strategy. This hypothesis also mentions the alternative, using smaller, specialized, Lego-like SLMs, small language models, composed together, maybe cheaper, faster, easier to debug, a different path to general capability. Big challenge here is balancing broad ability with deep, reliable expertise.
Then, hypothesis 2, deep personalization and proactive goal discovery. This suggests agents become truly personalized partners, not just waiting for commands, but anticipating needs, sometimes before we even know them ourselves, for your goal. Picture an agent, after the initial crisis help, proactively suggesting next steps. Maybe trauma-informed therapy options, local support groups, financial aid info, based on learned patterns in the individual situation without being explicitly asked. Of course, the design here needs extreme sensitivity. Proactive must feel supportive, empowering, not intrusive or pushy. It has to align perfectly with the survivor's needs and consent.
Hypothesis 3, embodiment and physical world interaction. Agents breaking out of the digital world into the physical one. Less direct for crisis response maybe, but intriguing possibilities. Could embodied agents interact with smart home security, lock doors, activate cameras based on threats, or maybe operate physical safety alert devices? Or even act as a discrete physical companion for someone feeling vulnerable. Blurs the line between digital and physical safety. Huge implications for assistive tech.
Hypothesis 4, the agent-driven economy. This predicts highly autonomous agents becoming active economic players, creating new markets, new business models. For your mission, maybe less about direct intervention, but could be powerful behind the scenes. Agents optimizing resource allocation for crisis centers, managing aid supply chains, running fundraising campaigns more efficiently, freeing up human effort for direct survivor support, cutting down administrative load, intelligent resource management for maximum impact.
And the last one, Hypothesis 5, the goal-driven metamorphic multi-agent system. This sounds like the ultimate endgame. Systems that operate not from detailed instructions, but just from a high-level declared goal. You state the outcome, the system figures out how to get there. It would dynamically change its own agent workforce, creating new specialists, retiring others, reconfiguring roles, all autonomously to meet the goal. Plus, they'd be self-improving at both the individual and collective levels, constantly optimizing themselves.
Yeah. For crisis response, that's the truly aspirational vision, isn't it? You declare the intent, provide comprehensive, safe, effective support to individuals experiencing domestic violence. And the system just does it and automatically spins up, modifies, orchestrates the right team of agents, triage, resource, legal, emotional support, safety planning agents in real time. It constantly optimizes their structure, their prompts, based on the survivor's evolving needs, learning from every interaction to become this incredibly effective adaptive support network. It's a fundamental shift towards true self-organizing, self-improving systems serving a critical human need. Hashtag outro.
Wow. That was quite a journey today, wasn't it? Really covered a lot of ground. We've navigated this whole landscape of agentic AI, understanding what an agent is, seeing how they've evolved through those levels of complexity, and really appreciating why these agentic design patterns are so absolutely vital for building systems that are reliable, responsible, and actually make an impact. This book, Agentic Design Patterns, it really does feel like an indispensable resource for any developer wanting to move beyond the basics and build what's next in AI.
Definitely. And just to reinforce that core message,
Yeah.
an AI agent is a huge leap from older models. It's an autonomous system. It perceives, it plans, it acts to achieve goals. And the tech is evolving incredibly fast, from single agents using tools to these complex collaborating teams tackling big objectives. Those future hypotheses, generalist agents, personalized partners, even physical agents, agent economies, they point towards a major shift. We're heading towards self-improving, goal-driven systems that could automate entire workflows and really redefine how we interact with technology.
So as you, our listener, continue on your path, we really hope you'll actively engage with the book. Run the code examples, experiment. Play around with these concepts. Think of this deep dive as an invitation, really. An invitation to reflect on these core ideas. They provide that essential foundation for building what's next and for pushing the boundaries responsibly.
And specifically, as you embark on building these incredibly powerful agentic systems for domestic violence crisis response, here's something to ponder. What's the most challenging, the most nuanced human element of crisis intervention? Maybe it's interpreting subtle fear cues, or building trust in just one interaction, or navigating the complex emotional journey of a survivor. What is that element that you believe an agent, if designed meticulously with these patterns and principles, could uniquely augment, not just automate, but truly augment, thereby freeing up human responders to focus their irreplaceable empathy and expertise on the most critical, highest touch aspects of their work?
That is a powerful thought to carry forward as you apply these amazing tools to such a vital cause. Thank you so much for joining us on this deep dive today. We are genuinely excited to see the impactful solutions you're going to build.